Good morning, I'm Tod Sutherland. I'm with Tropic Supply. I'm an HVAC consultant for the Central Florida area and also do some training for Tropic Supply. Today we're going to talk about the Allied equipment. Here I've got a 3-ton Allied heat pump, and over here we have the BCE 5E air handler, which is the X13 blower air handler. Some of you deal with straight cool equipment more so than heat pump equipment, but everything I'm going to be talking about today is going to be the same for both straight cool and heat pump. So the majority of everything we're going to be talking about today. First thing we're going to do is take apart some panels on this, talk about some of the features and benefits on this unit, some of the things that Allied's done with this, and then after we get done with that, we'll move over to the air handler and go through some air handler and some installation tips on the air handler. So let's get started. The first thing we'll talk about down here is service valves. The service valves are a little unique, and I've got one here. On the service valves, they don't use an O-ring inside the service valve. It's an all brass valve and it's a brass cap. And when you put the brass cap on the brass valve, all you have to do is tighten that an eighth of a turn, and the brass actually digs into the brass of the cap and creates the seal. So you don't have to worry about O-rings. And on top, can you see that okay? On top of every service valve that you have on there, you'll see that it tells you how much to turn that to tighten that down with your wrench. Okay, that's going to be on both your liquid line service valve and your suction side service valve. Okay, now aside from the service valves, the next thing that you have is you'll see this panel here, your little window. Go ahead and pull that off of there. When you pull that panel off of there, you'll see you get better access with your testing equipment to get inside there, put your clamp-ons on, take your measurements, all you can do while you're still leaving your electrical panel and everything all intact. Oh, of course, I'm supposed to state before we start this, anytime you're working on equipment live in the field, please wear safety goggles, please wear gloves, and please, above all, make sure you've disconnected power to the equipment, okay? Inside here, now this you won't have on your straight cool units, but these are your sensors for your defrost and your ambient temperature sensors are up inside here. The straight cool and the heat pump units come with high pressure switches. The high pressure switches are flared on high pressure switches with cores, so you can remove the pressure switches without releasing the refrigerant charge. This model heat pump that we stock, this is the 15 SEER heat pump. This model that we stock has both high and low pressure switches. The straight cool model will only have a high pressure switch on it, and that's the 4 AC16 model, and this is the 4 HP 15 model. On the electrical panel, 2 screws. And you can wiggle this out. If it's easier, you can loosen these 2 screws, but you don't need to. They don't attach to the panel. Inside the panel is going to be your electrical diagram. Bring that up a little bit closer. Your electrical diagram and your charging diagram over here. Okay. And just like most unit, it's going to give you the model number that you're working with, along with the condenser and air handler matchup that you have. And it's going to give you a subcooling reading, and then it's going to tell you what additional charge you may need to start with. So I know you can't see that too well, but it's going to show you the model number, the subcooling. It'll tell you an additional charge to put in. These come charged for a 15-foot line set. So anything beyond that, you will need to adjust your charge. And of course, on expansion valve systems, we want you to adjust that charge based on subcooling. Okay. Inside the electrical panel here, you've got your installation instructions. Also, it'll come with a, oh, Jason, can we get down in here a little bit better? These units have a liquid line dryer already installed. If you can, okay, so it's back in here, but you have the liquid line dryers already installed inside these units. Some of them will have a muffler in there as well. This is where your common suction port is for when you're checking your charge in the heating season. Okay. These are your louver panels here. Now the cabinet itself is made out of a polyester paint coated metal, and it comes from the factory in rolls, and then they stamp out. But what you'll notice is there's enough heat generated by the stamping machine that when it stamps these louvers, it almost melts the paint over the edge that they've stamped out. So you have little to no bare metal showing on the louvers, even after they're pressed out. Okay, so we're going to take some more of this apart. One of the nice features of these is these louver panels for cleaning your coils. They all come off. Okay, I'm gonna lift up and pull that out. It's going to be hard to see in this video here, but in the bottom of this, let's see, you'll notice there's a little notch in the bottom of that fits over the bottom rail on that. So when you're putting these back in, if you haven't loosened this top, you'll need to bend this a little bit to slide it back on that panel. But all four side panels come off. And of course, the advantage there is it makes it nice and easy to clean the condenser coil. These corner posts come off as well, but you don't necessarily need to take those off. And what you'll also see here is there's about 3/4 of an inch to an inch spacing between the pan and the coil. So hopefully when you're putting any screws back in, you're not going to poke the tubing on the coil. One of the other things that I want to point out while we're talking about the coil is this is what we call an Omniguard coil. So the Omniguard coil is a corrosion resistant technology that Allied has developed. Instead of using aluminum tube, aluminum fin coil, it's actually made up of a couple of different aluminum alloys for the aluminum tubing. And then, of course, the aluminum fins are all aluminum. The end plates on it are all aluminum. And then this was all corrosion tested in Corpus Christi, Texas, where it's a very acidic environment due to all the chemical plants that are out there, oil refineries and stuff. It's a very harsh environment. The industry standard on these is to test them to 15 to 1600 PSI. All the coils from Allied are tested at 2500 PSI burst pressure. And then the industry standard on testing the coils, both the condenser coils and the evaporator coils, is running them through 250,000 cycles. And at Allied, they run them through 500,000 cycles. And they took what the industry standard was for corrosion testing and the lifetime of the coils versus the environment. And they set a standard for it, and then they set where they wanted to achieve. And when they were done developing these Omniguard coils, they actually exceeded what they wanted to do. So these are very good coils. The aluminum tubing is also a rifle tubing. So instead of the refrigerant flowing through just the center of the pipe of the tubing, there's ridges all the way 360 degrees around the tubing that go through the tubing. So that allows the refrigerant more surface area inside the tubing. It grips the tubing better, and it runs through the tube better to give us more heat transfer and more dissipation. Also, the fins. If you were to look at one of the fins, which it's hard to do here, but each one of these fins has actually 15 different edges on that little width of the fin. There's all different kinds of punch outs there that give it more surface area, and it gives it maximum heat transfer on those fins. And every single one of those fins that are on here have that again. And then the other thing that's unique about the Allied is they have a proprietary process that they use to adhere the tubing to the fins. So most of your manufacturers will run tubes through the copper or the copper aluminum and swedge that out to adhere the fins to it. What Allied does is different. It's a proprietary trade secret, and but it's much better than flaring out or swedging out the tubing to adhere to the aluminum fins. Okay. Let me take this other panel off because I want to show you something. Other nice thing about this is all the screws are the same size. Okay. Big advantage when you're putting it back together. Oops. Okay. Now, what you'll see here is you can remove this panel. I'm not going to do that today because this is a unit that we are going to put back together and sell to one of you guys. Okay. But you have 2 screws up here and there's a couple of screws down here. Now, if you clip this here, you'll have enough wiring that you can pick this up and lay it over on the side to move this panel out. Okay. Now, some of the things you'll see inside here is all the expansion valves that they use are chat lift fittings. Okay, so no sweat connections, stainless steel bulb, and something also that you'll notice unique about these, if you were to look inside this unit, you'll notice that the expansion valve bulb is not wrapped. Okay, it is clamped onto the copper tubing, but it is not wrapped. When I questioned Allied about the reasoning behind that, they have test chambers up there where they test these in extreme weather, all the way from in the negative 30s, 40s, like we're experiencing in parts of the country now, up into the low 100-degree temperatures, 110, 115. I'm not sure quite how high they go, but they do test these from both extremes. And when they're building this piece of equipment to develop it for the SEER rating that it's looking for, what they found is with this stainless steel bulb clamped onto the copper tubing, that whether it was wrapped or unwrapped, it was getting enough heat transfer to adjust the valve that there was no need to wrap it. So you'll notice that these bulbs are not wrapped inside there. Something else you'll notice is this is the distributor tubing that's on the bottom of the valve, okay, going to the condenser coil. All of these are wrapped in a protective rubber casing to help against chafing. You know, we've all seen it where the tubes rub together and end up leaking. So on any of the distributors that go in both the indoor and outdoor unit, they have the wrapped tubing on there, which is a great benefit. The other thing you'll notice is they use a heavy duty fan blade. This is one of the fan blades that are on there. They use 2 different types. They'll use this type, and then they use another type that has ridges in it. They give a sturdy bend to the fan blade on there. Now, last but not least, the fan venturi, something that is becoming more and more common. They have about a 6 to 8 inch fan venturi inside here. It's a plastic ring that goes around the entire top of the condenser. And it's important if you're replacing a fan blade to make sure you position the fan blade properly inside that venturi. So you want to look at how high the fan blade is up in that venturi, so when you replace it back, you put it in the same spot. And typically on the top edge of the fan blade, you're going to want about that much of the fan blade up inside the venturi. Okay, not this much, not all the way up in the venturi, just that leading tip of the blade up inside that venturi. Now, the whole purpose of that, you're running the unit course, we want to make full use of our condenser coil all the way from the bottom all the way to the top, okay? And without that venturi, there's enough centrifugal force from the fan blade that if you were to take a piece of paper and put it down here on the condenser coil, the air sucking in will hold that paper, okay? So we know we're getting good airflow over there, but as you move it up the condenser coil and you get further up the condenser coil, right about here, you start losing that suction because of the centrifugal force of the fan blade and the outward pressure that it exerts. It starts pushing that air out and your piece of paper will blow off. So without that venturi, you lose a lot of capacity of your condenser coil. With the venturi on, you can take your piece of paper, put it anywhere on that condenser coil, all the way up to the top, all the way down to the bottom, anywhere on that condenser coil. It's going to be adhering tight because the venturi is drawing and pulling that air up, forcing the air, all the air out the top, instead of allowing for any centrifugal force to push out away from the condenser coil. One of the other things on this unit is on the pan. I mentioned that the coil sits back a little bit from where the pan is. It's also, you can see it's raised up off the ground. And then the coil is also raised slightly up off of the pan itself to allow for better drainage on the unit. Rest of this is pretty cut and dry. You got your connections up here, your capacitor, your scroll compressor, and that's really about it. Is there any questions on the condensing unit?
I don't see any. And as a reminder, everybody, go ahead and type them in the chat if you have any questions.
Yep. I was gonna say I could take that further apart, but let me see.
Oh, I have one question. Is it quiet?
Yes. Yes, with the venturi, with the fan, these are very quiet unit. They're in the, I want to say they're in the low 50s, maybe mid 60s on decibels on the unit. So yes, it's a very quiet. Oh, one more thing on this, on the defrost cycle. Can you see these tubes here? But these, basically what's happening is when you go into the defrost cycle, of course, we're switching back from the heat cycle to the cool cycle. We're running the hot gas from the compressor through the condenser coil to defrost the coil. The way they have this engineered, the hot gas enters the condenser coil from the bottom up. So where most manufacturers defrost the coil from the top down, they defrost the coil from the bottom up. Now, what difference does that make? The difference that makes is if you're defrosting the coil from the top down, then all that ice, water that you're defrosting has to run down the entire length of the coil. And as it does, if you come out of defrost too soon, it can refreeze. So you start building more and more ice up at the bottom of the coil. By defrosting the coil from the bottom up, you eliminate that entirely. So you won't have that issue that we see often in a lot of other brand condensing units where the ice starts to build up and cake up on the bottom of the coil. These units also have on the heat pump models, they have what's called quiet shift technology. So with the quiet shift technology, what it does is, again, anytime we're energizing the reversing valve, the compressor and the compressor is going to cycle off. It's going to give the system of, it's not long, I want to say it's only about 30 seconds that it lets the system equalize pressures before it shifts the valve. So you won't have that loud going when you're switching the valve over. Quiet shift technology, it's called. So we've got the fan venturi we talked about the Omniguard coil. Okay. We talked about the quiet shift technology. I think I've pretty well covered everything on that. You do want to look into your manuals on your line set length. So again, on the inside of the panel, it's going to tell you how much refrigerant you need to add to the system. And that's just going to be per matchup. So in other words, if you were to match this 3-ton unit up with a 3-ton air handler, you need to look at the chart Okay, and even for the 15-foot line set that this is charged for, you may need to add a little bit more refrigerant for that. And then if you add any extra line length, you'll need to add refrigerant definitely for that line length. And again, we want you charging by subgroup. Okay.
Todd, real quick,
Yes.
I have a couple other questions that came in that should be able to quickly answer. One is, what is the bottom pan made of? Is it plastic, stainless, etc.?
It's a pressed metal.
Galvanized?
Yeah, it's a galvanized pan. It's a very, very thick pan. Glenn, are you on the call? Is Glenn Patel on the call?
Yes, yes.
Is he mic'd up?
I do not know, but he is in the chat.
Yeah, Glenn, you can unmute yourself and pipe in anytime.
Okay, I think, can you hear me now?
Yes.
Yeah, you're right, Todd. That is a galvanized, thick metal pan. We've had success with that. We haven't had much corrosion. I was hoping you'd talk a little bit about the factory tour and the fact that the leak testing, the 7 points of leak testing that we run and how we run.
I was going to get to that.
Oh, okay. I didn't know.
No, that's fine. So full disclosure, when I went to the Allied factory, wasn't sure what all to expect when I got there. By the time I left, was completely overwhelmed with the technology that they use out there, the way they leak check the equipment. They have chambers that they use helium with, where they measure not only the amount of helium and they use helium because it has a smaller molecule than what the refrigerant does. So if they can test for helium and they leak helium, then they're going to be able to find that leak better than if they just test it with refrigerant, because the molecules that make up refrigerant are larger than the helium. So they are not only charging these systems up with pressurizing the coils with the helium to check the coils, but they're measuring how much they weighed in. They're measuring how much they weighed out. It goes into a sealed chamber. Very impressive system that they use to check all the coils with. And then of course, everything's run down a line. It gets, 7 times, Glenn, that it gets checked?
7 times, and then every system is actually energized at the last station.
Yes, and then even after they box the equipment, they leak check it as well. They go through and wand the equipment, picking out certain ones in the warehouse that they check as well. So they go through quite a process on this to make sure that when this gets delivered to you out in the field, that it's going to be fully functioning and ready to go. Okay.
I have one other question as far as warranty. What is the warranty on these units?
Okay, so out of the box, the warranties have a 5-year parts, 5-year compressor warranty. Yeah, if you register the system, then you get a 10-year all parts, 10-year compressor warranty. Okay, and that goes the same for the air handler as well. You get 10-year all parts when the system's registered. All right, we're going to go ahead and move over to the air handler.
Hey, Todd.
Yeah.
Just one quick comment on the warranty registration. It's a very simple process. We created a website called alliednow.com. And if you go on there, the contractor can actually register the system via one of the drop-down tabs. It makes it very simple and easy to file. It can be done by the homeowner or by the contractor. alliednow.com.
Yes, and we would encourage you for the contractor to register those. In some parts of the country, they do actually let the homeowner register the equipment. Ultimately, it would be the homeowner's responsibility. But most of us out here, we encourage all our contractors to do the registration for the homeowner so that you don't have to go out there in 6 years after the 5-year out of the box warranty is ended and give them the bad news that they don't have that 6 or 10-year warranty that they thought they had. Okay.
Hey, Todd, I just want to make sure that this question was answered. Do you have access to the pressure switches and filter dryer from the bottom panel?
Yes. So the pressure switches, there's one right here. Okay. The other pressure switch is right here. Okay, and that's also when you're taking the expansion valve out, your cap tube connection is your external equalizer connection is also a bolt-on connection with a flare nut. Now, is it an easy reach? No, it's not. Okay, I mean, it's right in here. You can get to it. Me, I guess if I were going to do it, I'm going to loosen up the screws, and you don't necessarily have to take this whole panel off. But if you loosen these two screws and these two screws over here, that's going to give you enough leverage to lift this up so that you can pull this out and move it over and give yourself a lot more room to work. Okay, and I know a lot of guys, and it's all what you want to do in the field. A lot of guys would just prefer to go ahead and undo the screws around the fan shroud up here, take that off and lay it over and go down through the top. Okay, most of us know that anytime you take these apart, these units are easier to put together than other units after you take them apart. A lot of the units out there don't have these individual panels. It's all one complete wraparound. And when you take this off, you get that boing effect of the casing that's around, and trying to put that back together is a complete nightmare. These units are a lot easier because most of the time you're going to leave these corner posts intact. So when you go to set this back on, it's real easy to put these corner posts back in to hold it down, and then you can put your individual panels back in. And these do have edges on the sides of them here. Okay, so when you put that back in, it does give you, and there's a, Jason, just gonna slide over here again. Maybe come over this way. So you'll see right here, there's a, can you see that? There's a groove that runs down here that panel locks up into. So it's not just sitting there waving back and forth on you when you have the top off. It does kind of lock into this groove on the right side of the panels all the way around. Okay. All right, now we're going to move over to the air handler. This is the BCE5E air handler. All the air handlers that we stock at Tropic Supply on the Allied models are BCE5 models. We have the BCE5E and we have the BCE5C. The difference is the C stands for permanent split capacitor motor. The E stands for ECM motor or X13 motor. And if further down the road, we may bring in the V's, which would be a variable speed motor. The other air handlers that we stock that we're not really going into today, but are the BCW air handlers, which are the front return air handlers. We do have those available as well. The width on this, they've maintained 22 inches deep, 21 inches wide. Let's tear it apart. First thing we'll do is take these off. A smarter guy would have started at the bottom. You don't have to completely remove this screw, but I'm going to be taking this panel off anyways. This is just kind of holder screw here, but you can just loosen that and still take the top off. Okay, insulated door. Inside, you can see that they have insulated the blower. So this, what this does is gives it a nice quiet. You can almost feel the weight of that, even with that padding on. It gives it a nice hefty, heavy feel to it. So it makes it a nice quiet blower. You can see in the packaging here, they put this in here. A lot of times when we get shipments in from bouncing around in the trucks on the deliveries, coming to the warehouses, these blower wheels sometimes get damaged where, because nothing like this is in there, they end up getting bent, bounced down. We've had very little damage come in on these because of that and the packaging that they do. So we really appreciate that. We'll start at the top. This is where your electrical, your heat strips will go in. Just a side note, these panels, any of you that are installing the iWave cleaners, this panel makes a great mounting bracket. You can pull this panel off. You can spray glue it to the inside of the insulation here, and then you can magnetic mount your iWave here. Slide over this way so you can see inside here, Jason. Sorry, Jason's my cameraman here, doing a great job. So you could spray glue that right there, so you don't have to cut into the insulation to mag mount an iWave. And what I'll typically do is, if I mount it here, you can either mount it to where the emitters are in the center of the blower, or you want to mount it where the emitters are above the evaporator coil but below the blower. You don't want the emitters pointed at anything metal, because if you get too close to that metal, and by too close I mean within 3 inches of it, you can get backfeed on that can short out those emitters on the iWave. So if you're installing the iWave R, I would install it in this unit. I'd put my plate here, I'd magnetic mount it so the emitters were above the evaporator coil and below the blower, and I would mount it so the wires come up the top, so that you can run your wires underneath this metal bracket here and zip tie it to the bracket to give it a little better security on the plate you've mounted it. And then there's a hole here you can run your wires up into to make your connections. Okay, so just a little side note on that. While we're aimed at this, you'll see that this insulation is all one piece from top to bottom, front to back, across the back, back up the other side. It's all one piece of insulation. It's not sectioned in there. It's glued in as well as held in by these bars up here. Yeah, and then where this bolts in, of course, this is holding it in as well. And then there's a lip here that is tucked behind. So I've yet to see any one of these where the insulation is pulled away from the side. So that's been a good feature on that as well. On your wiring over here, let's talk a little bit about that. Now, well, let me pull this panel off so we can go ahead and pull this off, so you can see what I'm talking about on the configuration. Again, all your screws are the same size, which makes it very, very nice. Before I pull this door off, if you'll notice right here, it says microband. Can you see that, Jason? Okay. All right. So right here, it says microband. Microband. Okay. So we have OmniguardTM for the coils. We have microband for the pans. So with the microband, what they're telling you is that the horizontal drain pan and the primary drain pan are infused with microband. So what that is when they get the microband in, they basically get these 55-gallon drums of all these tiny, tiny, tiny little beads that are infused with an antimicrobial chemical. And they use those beads in their processing as they melt them down to make these pans with. So the entire pan is made and infused with an antimicrobial. So that helps significantly on your mold growth and build up in your drain pan. All right, so I'm going to pull this off. Set that over there. All right, so you'll see that the coil comes set up horizontal right. Okay, and we'll talk about that later on horizontal right versus horizontal left. When you mount this horizontal right, I want you to slide over here. This is your electrical connections up here. Now this is mounted on a plate so that you can move that. Yeah, you can go ahead and slide that up. Okay, so this is where your blower relay and your transformer is, and it's mounted on a metal plate, and it's a multi-positional plate. So the whole process here is that when we lay this down horizontal right, this is now going to be sitting at the bottom of the air handle. Okay, we don't want any moisture or water penetration affecting this. So if we were to say lose a blower motor and our coil ice is up and we end up with water that may be overflowing the drain pan, and as it seeps down through here, we're now creating a potential hazard with this being in water. You can remove these two screws, and it's hard to see, but there's a little cutout down here. Let me see if I can do this. Okay, so you'll see there's a slope to this here, and then it tucks into a little slot back here. Okay, so you can undo these two screws, pull that out. There's another slot up here to where you can put that up here, and screw it into these two holes and fit the edge of that into this slot over here. Now, to take that even a step further, what the factory would like you to do is take this plate and move it over to here. Okay, so now when you're laying this down horizontal right, this is going to be at the top of the unit where you don't risk any water damage affecting the electrical. Now you do need to be aware that obviously when we take this plate off, we're now going to have to swing this plate this way. And obviously we can't swing it that way because the transformer and the blower relay are mounted to that side of the plate. So you'll need to unscrew the transformer, unscrew the blower relay, put them on the other side of the plate, screw them back in, mount them up here and put your screws in. Okay. It may sound tedious, but it's really a quick.
Trouble hearing you.
Oh, sorry, Siri, I wasn't talking to you. It seems like it's bothersome or what, tedious or whatever you want to call it, but it's 4 screws. You undo them, you switch them to the other side, and then you can mount that up there and be sure that it's completely out of the water. Now, when you lay this down horizontal left, you really don't have to worry about that because it's already mounted up there. Your transformers come tapped for 240 volt. So if you are putting these residential air handler in a 208 commercial application, you do want to make sure you change the transformer to a 208 tap, and that's simply changing out your tap on the transformer. Now your blower motor, okay, it's like I said, it's an X13 motor. You've got your yellow, brown, or your green, brown, yellow, white, and black wires coming out. You'll see up here. Okay, and one more thing, the reason this looks like this is because you're going to be changing these wires in a lot of cases. So again, after you're done, if you're not going to be using the yellow because you're going to be using the brown, which I'll explain in a second, or you're not going to be using the white, you're going to be using the black. Once you make those changes, then yes, please go in here, zip tie, clean this up, get it out of there. But it doesn't make sense to really do that prior because you're going to be making these changes. Okay, so your green wire coming into the motor, that is your G speed, for fan only when there's a call for cooling. Glenn, I'm not quite sure on this. Do you know if your blower runs at a reduced speed when there's a call for just fan only? Or
Yes,
does it
it does.
run at, okay. So it
runs-
runs at a percentage less, probably 50%. That's the way most of the X13 motors run. So if
Correct.
you just have a call, what's that?
That's correct, 50%.
Yeah. So if you just have a call, when you go to the thermostat, you push it to fan and you're only calling for fan only, it's going to run at half speed. Okay. Now your next wire is your brown wire. And like I said, your brown wire is not tapped. Okay. Now this is important because this comes into play in your half-ton sizes. So if you're installing a 1.5 ton, a 2.5 ton, or a 3.5 ton air handler, you're going to need to use this brown wire. Okay, because when you install a 1.5, a 2.5, or a 3.5 ton air handler, you are actually using a 2 ton, a 3 ton, or a 4 ton air handler. Okay, and those are set for 400 CFM per ton. So you're going to be oversizing your blower for the matched condenser that you have outside. So like this particular unit here, what size do we have here? Okay, so this is a 3 ton unit. So on the 3 ton unit, if I were going to be using this 3 ton unit on here, on a 2.5 ton outdoor condenser, then you're going to want to follow your yellow wire Okay, which comes right in the back of Y1 here, and you would want to remove that and put your brown wire there, and that's going to take that down a half to that half-ton size. Okay, now your black wire, same thing with your black wire. Your black wire is for high static, and that's mainly going to affect the heat side on that. Don't believe it really affects the cooling side. Because what you're going to do is where your white wire comes off of your panel here and goes into your blower relay up here, you're going to remove that white wire and put your black wire in there. Okay, and that's going to give you high static blower speed on that fan motor. Okay, so the most important thing to remember is when you're changing, using a half-ton size, you want to change that blower tap to drop that down a half-ton to match your outdoor condensing unit. If you're using it on even tonnages, or not even tonnages, but not half-ton sizes. So in other words, your 2-ton, 3-ton, 4-ton, or 5-ton, you don't need to make that change. Something that we've been learning over the course of the last 3, 4, 5 years on these is that these X13 motors operate best at 0.5 static pressure or below. Now, some of the installation manuals that you have with different manufacturers may show you ratings up to 0.6, 0.7 static. I don't think any manufacturer goes higher than 0.7. With these, the ratings that you'll see go up to 0.5. We just find that if you run higher than 0.5 static pressure on these, the blower motors they become less efficient, they don't work as well, and they tend to burn out faster. So it's important if you're replacing a PSC that you check your static pressure, your supply return static pressure. You may need to add a supply, you may need to add a return. Most of the time it's increasing the size of the return to get that static down. So please make sure you pay attention to that. Again, we talked about the microbial drain pans. Again, if you'll see down here, you've got the chat lift connections on the expansion valve. You have the rubber tubing on the header going to the coil. Again, this is an Omniguard coil. On the Omniguard coil is in both the outdoor and indoor unit. You also have a filter base built into the bottom of this unit, and it comes with a filter. Okay. Now let's talk about the fun part. So one of the things that we are running into out in the field is there has been some issues that people have related to us with these air handlers sweating some. Most of the time, not all the time, most of the time it's an installation issue because the installation instructions that are often used for knee pads are not being followed or not being read. Okay. So let me remove this. So you do have to, in order to slide this evaporator coil out on this unit, you do have to remove this bar. Okay. Some of the larger units you may be able to slide out, but on most of these, you're going to have to remove this bar. It's just a couple of screws on each side. And again, what I love, that all the screws are the same size. Okay. So we've got this bar moved. Okay. We do need to remove the filter door access. You don't necessarily have to, but it definitely makes it a lot easier. Okay. And you see, got a filter in there. All right, so as you can see, we're set up for horizontal right application. Okay, now, this is important, and we're finding that it is not being followed probably 80 to 90% of the time. Okay, and all right, so if we're going to go to a horizontal left application, well, let me back up just a second. In a vertical application, they're still asking you to remove this drain pan. okay? It's easy enough. Obviously, the coil slides out. I'm gonna slide this out, and set it down here on the ground, okay? Can you get that? Okay, so to remove this drain pan, it's this simple, okay? Doesn't get much easier than that. All right, so in a vertical application, a lot of guys like to pull the coils out because it's easier to set the air handler into place. It makes it much lighter, of course. So when you have that out, take this drain pan off, put it in your shop, save it in case you need it on a rainy day. But remove that drain pan, okay? Now, if you're going to go horizontal left, okay, there are 10 steps that have to be followed. And if you're not following these 10 steps, you're going to create problems for yourself. The water's not going to drain properly. It's not going to go into the pan properly. You're going to end up with water inside the unit. And ultimately, you're probably going to end up with your cabinet sweating. Okay. So basically, we're not going to we'll walk through some of the steps, but not all of them. And I can tell you the first time that I did this and I went through these instructions that are on the top of this, they didn't make much sense to me. So if you follow the instructions and do it as the instructions are telling you what to do, you'll see it starts to make sense. So the first thing they're telling you to do is to remove the horizontal drain pan, which we did. Okay, then it's telling you to, if these plugs aren't installed, to remove the plugs and put them in the other side, but you know, we don't need, you've got plugs, comes from the factory with plugs on both ends. Okay, so what you're going to do is you're going to take this and you're going to move it over to the other side of the pan. Move it around here. And again, it just slides on just like we took it off the other side. Okay, now unfortunately, a lot of guys out in the field are stopping there. They're putting the pan on the other side, they're putting the coil back in, and off they go. There's a lot more steps to that, okay? Next thing that you're gonna do after you rotate this is you gotta remove this top cap. And we'll go ahead and do that so you can see what I'm talking about, okay? And if you wanna quickly check as to whether or not this has been done, there's a real easy way to do it. It's all based on this pan. What you'll notice is on this side of this drip ledge, that is a 90-degree bend, okay? On this side, it's a 45-degree bend. When this coil is laying down in this position, if you open up your cabinet and you look inside there and this 90-degree bend is still on the top, then that means they did not follow the instructions and they did not flip all this around the way they're supposed to. Okay, that's a real quick, easy way to see whether or not the coil has been installed in a horizontal left application correctly. Okay, I'm going to remove these screws. Now, I will tell you on these, they are a different length screw. So the coil, all the screws for the cabinet are the same length, but when you start doing these screws in here, they are different screws. Okay, they are definitely longer screws.
I have a question for you.
Yep.
What would be one of the side effects have somebody not flip that top panel around?
Well, that's what I was saying. Your main side effects is it's not going to drain properly. Okay, so what we're doing here is, and you'll see when I take this off and pull the drain shield out, the drip shield, when we pull that out of there, you'll see that that has to be rotated 180 degrees because of the way this coil is going to be laying down. And if you don't do that, then it's not going to drain the water off the evaporator coil properly, which can cause the blower to suck the water out of the pan into the cabinet. And once you get the inside of this cabinet wet, now you're talking about mold and mildew issues. But also what we run into is with enough water inside here, we start getting the cabinet to sweat. So there are 8 screws that you take off here. Okay, put those there so I don't lose them. All right, so we remove the coils from the top cap. We're going to remove, okay, this pan, this cover right here. Okay, now in the back, the next step on this, it says to remove the horizontal drip shield screw. Okay, and it tells you it's in the back center of the coil. So if you were to look, there's a screw right here. Okay, I'm going to go ahead and remove that screw. Okay, and again, that is a different threaded screw. So make sure you keep track of those. Okay, and put them where you know to put that back. So now we're removing this, and you see that drip shield in there. Okay, so that drip shield, and you see it's almost like a pan in itself that is going to catch, when this is in a horizontal position, it's going to catch some of the water and divert the water so that it goes into the pan the way we want it to go in the pan. Okay, and if you leave this in mounted like this, then when you lay that down, the pan's going to be on top of the coil instead of on the bottom side of the coil, and it's not going to catch any water, and it's not going to direct it or divert it. So you're going to pull that out of there. You're going to rotate it 180 degrees, and you're going to carefully slide it back in here. Okay. Once you've done that, you'll see right here on the front is a little plug. Okay. It's a little tiny black plug. Okay. See if we can get a little better. All right. This little tiny black plug, that's in the same spot that the screw is in that I took out on the back side of the coil. So what are we going to do? We're going to pop that black plug out. We're going to put it in the back of the coil where I took the screw out. And we're going to take that screw and we're going to put it in here where that plug is. And that's going to keep our drain shield in place. Okay. After you've put that back in place, you're going to turn your cap around 180 degrees again. So the 90-degree bend is on the side of the pan. 45-degree bend is on the opposite side. Okay, and that's going to slide on there. You're going to put that back on there, and basically you're done. Now you're going to put the coil back in the cabinet. Okay, but it's important that you take those steps when you're doing this in a horizontal left application, or you're just going to be creating problems for yourself. Okay, that is, I think, everything I have for today. Are there any questions on that? Any?
I actually do have a couple questions. And so when these air handlers are installed in light commercial applications and somebody needs to hook in a fresh air damper, is that G wire, does that receive a 24-volt call continuously anytime there's a call for a fan, or is that lose the call and then switch over to the high speed, if that makes sense?
No. So no, whether it's a call for fan only or whether there's a call for cooling, okay, so you're going to be energizing Y1, both your G terminal and your Y terminal will be energized.
And okay, perfect. So they would hook up into the G terminal would be the preferred method to hook up that damper to open and close?
Well, that depends. That depends, because if they only want that damper open when there's an actual call for cooling, then I would connect it to Y1. If they want it anytime the fan's energized, which you're right, Tim. Probably most of the time they're going to want that anytime they're circulating air, anytime there's a fan. So yeah, you'd probably go to G.
Okay. My only other question is, and I've had to deal with this when I was a contractor, we got to put this unit up in the attic and we kind of need to almost completely disassemble. Does that, that bracket that the blower mounts to, is that able to be removed?
Ugh.
I'm sure it wouldn't be easy, but just curious.
Yeah, I mean, yes. I mean, obviously, yes. So to answer your question, yes. Now, like you said, is that a task? By all means, because you'd have to remove this. You got your two screws here that you're going to have to remove, and then you've got screws here that you're going to have to remove because this plate is also screwed into this top plate. So it would take you a little bit of effort to do it, and but you can do it. I actually had a contractor that had to get some condensing units up on the roof, and they had no way to get them up there because of the position of the building. They couldn't get a crane to do it. The doors weren't big enough to bring the condensing units up to the roof. So they completely disassembled the condensing units, brought them up there piece by piece, and then reassembled them on the roof. So anything can be done. It's just whether or not you want to take the time to have to go through that. So, but yes. Oh, one other thing is there was some complaint in the past about the knockouts for the high and low voltage on these units and the difficulty of knocking them out. That has been addressed at Allied, was addressed. Glenn, you may know this better than I do, how long ago that was addressed, but they changed how they stamp these out and made it considerably easier to knock those knockouts out.
Yeah, we have to test for that because if that's a matter of that pressing tool becoming dull over time and not cutting that metal to the right parameter for an easy knockout. So we put a protocol in where we check that on a monthly basis, that the depth of that punch, so that it makes it for an easy back of the screwdriver punch, as opposed to using one of those special tools to knock it out. Hey, Todd, I wanted to mention also about another, like about AlliedNow.com to all the guys. There's also another great Allied website called AlliedRatings.com. And on Allied Ratings, you just click on the Allied logo, and only the Allied product line will populate in AHRI. So it really makes it easy. You're not having to fight the AHRI master portal. Allied Rating.
So you can go to, so Nicole, let's make a note to send both of those websites. You're going to get an email from Nicole after this webinar is over, where you're also going to get a survey, which Nicole will tell you about. But we'll send everybody that's participated an email, and we'll put those two links in there. But yes, I use that Allied Rating site all the time. You go into the Allied Rating site, and you can pick the condensers and air handlers that you want, and it gives you the different ratings. So you can see your different combinations, and it gives you the AHRI rating on that. Something else I want to point out here on this at the bottom of the air handler, this bracket that the evaporator coil sits on and the bracket that the filter rack is in is a really thick, heavy metal. So you don't run into that sloppiness when you're trying to put these evaporator coils in, and you're not going to risk that bending or settling down on top of that air filter either. And the other nice thing is the way they have this built into there, you're going to have a lot less blow by on that air filter than you do on other units. Is there another question?
No, I believe that's it. The only thing I would definitely want to point out is one, you did a great job showing converting the coil to for the drain pan. But I'd like to point out that as a technician that's going out there in the field diagnosing a sweating air handler, that would probably be one of the first things I would look at to see if the coil was switched properly.
Yes, and like I said, if you look at this, you'll see that one side, that's a 90-degree bend, okay? And the other side is a 45-degree bend. So that 90-degree bend should be facing the drain pan. Where'd my pan go? So here's my pan. That 90-degree bend should be at the pan. If the 45-degree bend is at the pan, then you know it hasn't been done. Okay. Another quick and easy way to check and see if it's been done is look at this coil, and we talked about this black plug. Okay. If you look in, if your air handler is laying down horizontal left, and you take your coil door off and that black plug sitting there, they didn't swap it around. Okay. There should be a screw there if they swapped it around. So a couple of quick, easy ways that you can just snap a picture, and see if that's the issue. And unfortunately, if it is, then you're going to have to pull the evaporator coil out, swap it around, and make those corrections.
I do have one other question. It's not necessarily a full question, but he just put speed taps ? And I think you kind of went over that already. And most of the information will be in the manual, I assume, as well.
Yeah. I don't have an open manual here, but but you can download the manual. But yes, in the manual on page, I think it's page 16, it goes through every combination and it'll show you that the 2-ton air handler comes tapped for 2 tons and that you want to change the yellow wire to the brown wire to go to 1.5 ton. Same thing on all the others. And the same with the black wire. You want to change the black wire from the white wire if you need to go high static. Now, Glenn, this is something I wasn't quite sure of. I apologize for not getting this information ahead of time. I don't know if you'll know this or not. But I have to assume that if we're replacing the white wire, which is only energized for heat, with the black wire for high static, then that's only going to energize that high static speed and call for heating, not cooling.
That sounds right, but I would have checked on, I'll check on that with engineering and make sure we get the right answer.
Yeah, we'll double check that, but, and that's basically because they're not wanting you to use that high static in the cooling mode. They're wanting you to reduce the static pressure and get it in the correct tolerances. It's basically what they want to do, but we will get a clarification on that.
Hey, Todd, I don't want you to get too excited like you're going to get done so early, because I have two requests. One, they want to see that that insert that you have to switch around inside the coil there at the top, that drip pan, that
Okay.
right there. They want to see that again, and somebody wants you to remove the blower as well. Bump up.
Okay. Okay, we can do that. So this is the drip pan. There's a little close-up view of it. So you can see it's like a mini drain pan, okay? And a diversion here that it is hard to see, but it's basically when it's inside there, okay? It's directing the water that comes off of this part of the coil into this pan and diverting it down into the slot trough here that goes down into the actual drain pan, okay? And like I said, if you don't swap it around, it's going to be when it's laying down, it's going to be sitting like this, okay, on that side of the coil. So obviously we have to take it out, we have to flip it around so you have that drip pan there, okay? And was that one of my guys that wants me to remove the blower?
Actually, it's not. It was one of your guys that wanted to see that part that you just showed. It is it wants to.
Okay.
Yeah, and it was Garrett that wanted to know about the speed taps.
Yeah, I figured. So you're gonna loosen these screws. Okay, you don't have to take them out because they are notched over, but you do have to loosen these screws. Okay, and then you take this, slide it over, and you can move that out of your way. And then it is, I may not be able to do this because I don't have the elongated stem on this, but let's see if I can get in there. But there are one, two, and again, you can disconnect these plugs.
I'm making you earn your money today, Todd.
I'm telling you. Well, anyways, you disconnect those plugs and you have to lift it up and it slides out. Okay. I'd have to completely unwire that in order to do that. So I'm not going to do that. These plugs, there we go. Boy, they got those in there good. Here we go. So take those two plugs out there. And there's your blower. Okay.
That man raised.
So, all right. Now I don't want somebody to come on there and say, okay, now put it back. I'll do that afterwards. And I'll make sure that we send this combination system over to Garrett, just for you, buddy. Okay. So are there any other questions on that? Again, Omniguard coils on the condensers and the air handlers. Well, I won't say any more because we do have some quiz questions coming up. But are there any other questions?
I don't see.
All right, Nicole, do you want to take over from here?
I can. There was one more that came in. How
How do you take the blower wheel out to clean it? You're
Yeah.
gonna do that just like you would any other unit. You're
Yeah.
gonna
Yeah, I
gonna
mean,
take
it's
the set screw.
yeah, it's the
and-
same blower housing as any other blower housing. Okay, I mean, it's no different than every other manufacturer's blowing housing. There's your mounts, there's your blower wheel. So you're gonna, do it just like you would do any others. All right, Nicole, you're up.
Okay, I'm gonna go ahead and share my screen. Can everyone see my screen? I'm guessing you can.
All right, so everybody get their keyboards ready and get ready to type fast.
Yes, so make sure it goes in the chat. So let's go. Question number 1. What is Allied's total corrosion protection technology called? Okay, question number 2. True or false? Both the vertical and horizontal drain pans are infused with an antimicrobial agent. Okay, question number 3. True or false? The BCE5 air handlers require an added filter base and filter. Alrighty, question number 4. True or false? Only indoor A coils are built with OmniguardTM total corrosion protection technology.
Any other questions before we go? I know Nicole's got a survey that's going to pop up as soon as you guys log off. Please take a little minute to give us some feedback, the good, the bad, the ugly. We want to hear it. We want to continue to get better on this. So any kind of feedback you can share, Todd, would be very happy to hear.
Yes. And like Heather said, we are definitely going to be doing more of these. So, if there's topics you want to see done, anything, and it doesn't have to be this kind of environment. If there's actual live demos that you want to see, we've got equipment out in the field that we can do stuff out in the field with. So, I mean, anything you guys come up with, let us know, and we'll do our best to do the training for you.
Yes, and there's a spot in the survey where you can write that information, or you can always email marketing@tropicsupply.com. Outside of talking to your consultant or the resource center, we're always available to listen and, get you set up with whatever training you may need.
Todd, just a suggestion. Have you trademarked Tod Talks and the avatar?
Yes,
avatar's
Heather's been in
nice.
touch with my agent.
Hey, we want, training is always not, the most fun thing that we can do, but we want to make it as fun as we can for you guys. It should be fun learning new stuff. So,
Yeah, and what we're trying to do is bring real world into it too. Instead of we don't want to just send you a whole sales pitch. We want to, show you everything we're talking about. We want to do the dismantling of it. I believe our next webinar next week is going to be Wade's Words of Wisdom. Is that correct?
yes, Wade's Words of Wisdom. I think we're
Okay, and then we're going to have a
number 4.
Tim Talk coming up. The Tim Talk coming up is going to be the second of a series on the Samsung ductless mini splits, where he'll be taking apart, again, real world wall mount units that he'll be taking apart, showing you guys what to expect when you have these out in the field. So that's what we're trying to bring to you through these is real world scenarios, stuff that can actually help you out in the field more than just going through the bullet points on the product literature.
All right, no more questions. Everyone's saying great job. So thank you everybody for attending, and we'll see you next time.
Thank you.
Bye-bye.